Hi student, welcome to this lesson, determination of formulae. Under this, we are going to use two methods. One is empirical formula and the other one is molecular formula. So at the empirical formula, we are going first of all to define what is empirical formula, which is the simplest whole number ratio in which atoms combine to form a compound. And this one is usually done experimentally. Suppose you are required to determine the empirical formula of magnesium oxide. You need to carefully weigh the sample using apparatus. Then the results should be recorded carefully and accurately. As an example, in an experiment to determine the simplest formula, which is empirical formula of magnesium oxide, the following data was obtained. The sample data look like this in table form. The mass of empty crucible plus lead 20.82 grams given the number X. Mass of empty crucible plus lead and magnesium 21.78 grams given the letter Y. Mass of empty crucible plus lead and magnesium oxide 22.42 grams, letter Z. So how do you compute for magnesium, the mass of magnesium? You say it is Y minus X, that is 21.78 minus 20.82 to get 0.96 grams of magnesium. So for magnesium oxide, Z minus X 22.42 times minus 20.82 to get 1.6, and the mass of oxygen will be computed by subtracting 0.96 from 1.6. Since we know this is the mass of magnesium, so the difference will give us the mass of oxygen. So the mass of oxygen is 0.64 grams. The empirical formula of magnesium oxide can be determined as follows. First, remember you always start with the metal and then non-metal. The reacting elements are magnesium and oxygen. Reacting masses 0.96 and 0.64. RAM, or relative atomic mass, of magnesium is 24 and oxygen is 16. Therefore, the number of moles will be computed by dividing the reacting masses with RAM to get 0.04 moles. From oxygen, the same, you get the same, this 0.04 moles. Then for mole ratio, you divide with the smallest value, and this case it is 0.04 to get 1:1. Therefore, it means that 1 mole of magnesium combines with 1 mole of oxygen atoms. Therefore, the empirical formula, or the simplest formula for magnesium oxide, is Mg1O1, simply written as MgO. So here I want you to note that this one goes with the magnesium and this one goes with the oxygen. A student at Colanet Africa Lab conducted an experiment to determine the simplest formula of copper 2 oxide. So the following data was obtained: mass of copper 12.7 grams and oxygen 0.32 grams. Determine the empirical formula of the compound. Reacting masses, or reacting elements, copper and oxygen, while the masses is 1.27 grams and 0.32 grams for oxygen. RAM of copper is 63.5, while for oxygen is 16. So number of moles, you divide the reacting masses with RAM to get 0.02 moles, and for oxygen 0.02 moles. So mole ratio, is here. You divide now with the smallest value, and the smallest value is 0.02 to get the mole ratio as 1:1 after dividing with the smallest value. So copper 2 oxide, the empirical formula will be CuO. Chemical formula or empirical formula may also be derived from percentage composition of the constituent element. As an example for this is an oxide of sulfur was found to contain 51% mass by mass sulfur. So what is the empirical formula of the oxide? So the word oxide means that sulfur combined with oxygen. Reacting element, sulfur and oxygen. Percentage composition 51%. So the remaining 49 is for oxygen. This one, when you add, should make 100% because we are talking about percentage composition of the elements. Relative atomic mass, sulfur 32, oxygen 16. To get the number of moles, you divide the reacting or maybe the percentage composition. You divide by RAM to get 1.59, while the other one is 3.06 moles. Mole ratio, you divide with the smallest value. In this case, the smallest value is 1.59 to get one whole number, and the other one we get 1.92. It is good to note we are dividing the smallest value on both moles. Then for this, it is rounded off to the nearest whole number because it is nearer to a whole number. So 1.9, simply call it 2, rounding off, and this one will remain done. So 1 mole of sulfur combining with 2 moles of oxygen. So sulfur oxide is written as SO2. Another example to make this concept clear on percentage composition is that a metal X oxide has 70% X and 30 oxygen. Determine the empirical formula. Note, 70% plus 30 makes 100. That is one thing that you should note when you are dealing with the percentage composition. So reacting element X and oxygen, composition 70 and 30, RAM 56 for X, 16 for oxygen. Then you divide to get the number of moles. This one will get 1.25, while the other one is 1.875. So after you have done that, divide with the smallest value. This is where most students make mistake. So you don't move from this step and then you write the empirical formula. You must first of all divide with the smallest value. After getting the number of moles, you divide with the smallest value, and the smallest value is a 1.25. When you divide, you get 1, and you divide the other one with the same small value, you get 1.5. In this case, the ratios are 1:1.5. This one is not nearer to 2 or nearer to 1, so it is in between 1 and 2. Therefore, in this case, you multiply by 2 to make this number whole, and you do the same to the other one. You multiply by 2. So when you multiply by 2, you get 3, and this one multiply by 2, you get 2. So they will combine in these moles. So X will have 2 and oxygen 3. So the empirical formula of metal X oxide is X2 and O3. Here is a quiz. Quiz yourself, work all the questions. The answers are provided. Thank you, and let us meet in the next method of calculating the formula, the molecular formula. Bye. Thank you.